Hello and welcome to the second video and unit of Chemistry 11. Today's focus is going to be on the basics of chemical reactions. Firstly, what is a chemical reaction? Well, essentially it is a process in which the chemical properties of a substance is transformed. For example, we know that by combining oxygen and hydrogen together results in water. Let's write out this chemical reaction in a chemical equation here. In previous years, you learned to predict the product given a certain reactant. While the product is correct in this situation, the yield, or the amount of the product relative to the reactant, is incorrect. This is where we introduce a concept known as the conservation of mass in atoms. This law states that the mass and number of atoms of the reactant has to be the same throughout the reaction. You cannot create or destroy matter, so when you have a reaction, the product should have the same number of atoms and mass. Okay, so we know this, but how does this apply to the example of water? Well, let's go count how many of each atom is in the reactant and in the product. Okay, so if you look in the reactants here, there are 2 hydrogen atoms and 2 oxygen atoms, whereas in the product section, we have 2 hydrogen atoms and 1 oxygen. So, how do we resolve this? Well, in math, there are things called coefficients. These coefficients are used to multiply a certain value. In this case, we are using coefficients to balance this chemical equation. Because we have 2 oxygens on the left, and only 1 on the product side, we're going to multiply the product side by 2. Okay, now let's go count again. We now have the proper amount of oxygen, but we now have 2 more hydrogen on the product side than we do on the reactant side. So what are we going to do? Well, we are now going to multiply the hydrogen by 2. Let's go count again. There are now 4 hydrogen here and 4 hydrogen here. There are 2 oxygen here and 2 oxygen here. So that's equal. In other words, in nature, when hydrogen and oxygen are forming water, there has to be 2 hydrogen molecules for every 1 oxygen molecule, and those will form 2 water molecules. By the way, if you're wondering why hydrogen and oxygen are written as H2 and O2 respectively, it is because they are diatomic molecules. These elements never appear in nature as a singular atom. There are 7 elements that are diatomic molecules. These are hydrogen, nitrogen, oxygen, fluorine, bromine, and iodine. Now, it's not always as simple as multiplying 2 to everything. Okay, so now that you know all that, let's do some questions here. So, before we begin, let's go count how many of each element is on each side. So, right now we're dealing with 4 different elements. Okay, so let's count how many of each are on both sides here. So, we have 2 lithium on the reactant side, 1 lithium on the product side. Oxygen, we have 1 on both. Hydrogen, we have 1 on the reactant side and 2 on the product side. And finally, chlorine, we have 1 on both sides. So let's go balance this out. Firstly, let's go deal with the hydrogen. So if we multiply this by 2 here, now we would have 2 hydrogen on the reactant side and 2 chlorine on the reactant side. Now there's only 1 chlorine on the product side, which means that we should multiply this by 2. And funnily enough, when you multiply this by 2, not only do you have 2 chlorines on both sides, we now resolve the unbalanced lithium, so we have 2 lithium on both sides. So this equation is balanced. Let's try this next one. It's a bit of a handful and definitely a mouthful to say, but the process is basically the same. And by the way, before we begin, phosphate is a molecule, which means that you can't really separate it, so treat it as an element. So potassium, how many do we have there? We have 2 on this side, on the reactant side, and we have 3 on the product side. Carbon, we have 1 on both sides. Oxygen, we have 3 on this side, and we also have 3 on this side. Hydrogen, we have 3 on this side, and 2 on this side. And phosphate, we have 1 on both sides. Okay, let's go balance this out. So the first thing we balance out is the hydrogen. So let's put 2 on this side and 3 on this side and see what we get. So now we have the same amount of hydrogen on both sides, but now we should balance out the phosphate. So now there are 2 phosphates on the reactant side, and there is only 1 on the other side. So let's go multiply the phosphate on the product side by 2. But now there's 6 potassium on the product side, and only 2 on the reactant side. So multiply this by 3. And we finish this off by balancing carbon, which there are 3 on the reactant side and only 1 on the product side. So multiply this by 3. Let's go count over all of our elements here and see how many we have. So potassium, we have 6 on both sides. Carbon, we have 3 on both sides. That's good. Oxygen, let's go count them. So we have 9 on this side. On the reactant side, we have 3 plus 6. So yes, we have the same amount of oxygen on both sides. And then we have our hydrogen. We should have 6 on both sides, so 3 times 2 and 2 times 3, yes, they're both 6. And finally, our phosphates. There should be 2 on both sides, and there are. So this is a fully balanced chemical equation. Before we continue with some examples, there are a few more things that you should know about chemical reactions. Firstly, you should always write the states of matter, which the reactants and products are in. Oftentimes these are given to you, like in the water equation above. I tell you that hydrogen is a gas, oxygen is a gas, and water is a liquid. If they're not there, you can always just assume that the state is aqueous, unless you know for sure it is a given state. For example, you would know that oxygen and hydrogen are gases, and you would know that water is a liquid. Now, there are 4 states of matter that you should remember. There are solid, liquid, gas, and aqueous. The way you denote these, as you saw above, is with brackets after each chemical molecule. So, for solid, it's denoted with S, a lowercase s, inside of brackets. With liquids, it's a cursive L. With gas, it's just G in brackets. And with aqueous, it's AQ. So these are just 4 states that you should remember. So when writing chemical equations, you always use the addition symbol to indicate that there are multiple reactants or products in the reaction. So the arrow sign is sort of like the equal sign, and it basically means it yields or produces something. We use this to show that the reactants react to create a product. And finally, we have NR. It means no reaction. There are very specific scenarios where this will happen, but I won't dive into those today. Finally, we have some more questions. Finally, we have some more equations for you to balance out. I won't tell you how to do these. I'll only show the answer at the end. So this was part 1 of chemical reactions. Part 2, we'll dive into different types of reaction, and part 3, we'll actually start to dive into something called stoichiometry, where we deal with moles and masses, along with different types of chemical reactions. So I hope this video was helpful and insightful, and yeah, I'll see you guys next time. Bye.